Module 7, Lesson 1 covers solving one-step addition and subtraction inequalities. And you are going to find that this is extremely similar to if we were doing one-step addition and subtraction equations. In fact, there's only one tiny difference between working with inequalities and equations, and yet for some reason, y'all's brains just go every time I start throwing out inequalities. Hopefully we can overcome that today, and you'll be able to see that these things are just as easy as doing one-step equations. And the only difference, well, we're going to show that, but that's not going to be today's show. That's going to be, I think, tomorrow's show when we cover multiplying and dividing inequalities. So let's take a look here. We've got a content objective that says students will solve and graph one-step addition and subtraction inequalities. The suggested pacing says this is going to be a 2-day lesson, so let's get started in it and see where they take us. Okay. So they give us what they call an infographic that they want us to explore. First thing to look at here is that an inequality is a mathematical sentence that compares quantities. And it says, first off, you always read inequalities from left to right. An inequality sign opens to the greater number or the bigger number. Just like hungry alligators, they always want to eat more. Now, we won't even go there right now. Take a look below, and we're going to see the different inequality signs and what they mean. First off, you have less than. Less than means the number is smaller than the other number. So here, n is less than x. N is going to be smaller, x is going to be larger. For a place you might see this in the real world is on bridges. There may be a weight limit for a truck to be 20 tons or less. If it's greater than 20 tons, then guess what? You may break the bridge, and then people will be very unhappy with you. Greater than, n is greater than x. That means the value of n is bigger than the value of x. And that might come into an amusement park ride where it says you must be taller than or greater than 45 inches tall. Poor Yoda, he can't ride many amusement park rides. Next, we have less than or equal to. N is less than or equal to x. That means that n has to be smaller than x, or n could be equal to x, but it can't be any greater than it. The freezing temperature of water is less than or equal to 32 degrees. At 32 degrees, you get ice. At 30 degrees, you get ice. At 33 degrees, you get water. And finally, the greater than or equal to, n is greater than or equal to x. An example would be age restrictions. You must be greater than or equal to 18 years of age in order to vote. And the older I get, the more I believe they need to raise that to a much older age. Our inquiry question says, how does adding or subtracting the same number from each side affect an inequality? Well, let's find out. Suppose you're given the equation 5 is equal to 5. Right there. If you add or subtract the same number to each side of the equation, do the sides remain equal? Well, absolutely they do. So it says to take and prepare yourself to justify your answers, whatever. So here we have 5 is equal to 5. If we wanted to add, say, let's just add 3 to each side, and there it goes. It remains equal. Well, what if we wanted to subtract 8 from each side? And there it goes. It remained equal. Well, guess what? The same exact thing is going to happen with inequalities. As long as you do the same exact thing on both sides, you're going to have the same result. So here we've got, actually that's the same basic problem. They just wanted us to conjecture upon it. Alright, here they want us to do the same thing. Like now they say throw in some positive and negative numbers. So let's do a negative 6 in there. Whoops, back that sucker up there. Do a negative 6 and hit add, and whoop, look at that, it went straight down. Well, what if we try to subtract 1.9? That'll do that. Now if we wanted to take and subtract a negative, let's do a negative 9. And when we do that, boom, it's going to go the other way. Point being, it doesn't matter what you do as long as you do it to the both sides. If you do it to both sides, everything's going to stay balanced. From here, we're going to pick up the definition of an inequality. An inequality is defined as a mathematical statement that compares quantities. They usually contain the symbols less than, greater than, less than or equal to, or greater than or equal to. We can take and look at the less than, we can look at the greater than, we can look at the less than or equal to's and the greater than or equal to's, and you can see those are examples of what each one has. You guys have been dealing with that aspect of it since you were wee little kids, so I don't think this is going to be any great revelations to you here. Now let's watch an animation on graphing a solution set of an inequality.
To graph the solution set of the inequality, start by placing an open dot at 3.5. For an inequality that includes a less than or greater than symbol, an open dot is used to show that the number is not a solution. Next, draw an arrow from the endpoint. To show that values less than 3.5 are solutions, draw an arrow that points to the left. Consider another example. To graph x is greater than or equal to -1, start by placing the endpoint. For an inequality that includes a less than or equal to, or a greater than or equal to symbol, a closed dot is used to show that the number is a solution. Next, draw an arrow from the endpoint. To show that values greater than -1 are solutions, draw an arrow that points to the right.
Now once again, that's pretty simple. I don't think they have any great revelations for y'all here. You should all be familiar with all that information already, but a little review never hurt anybody. From here we get to start picking up some new vocabulary terms. Solving an inequality means finding the values that make the inequality true. It says you can solve the inequality using the subtraction property of an inequality. That's going to be a vocab term. You can also solve the subtraction inequalities by using the addition property of an inequality. That's going to be a vocab term as well. And you're going to find that these terms look very familiar to you because we've already done them with equations. So the only thing that's really changing is we're changing the word equation to inequality. In words, when you add or subtract the same number from each side of an inequality, the inequality stays true, just like with the equations. With symbols, if A is greater than B, and then A minus C is greater than B minus C. A plus C is greater than B plus C, and so on. And then in numbers, if 2 is less than 5, then 2 minus 4 is going to be less than 5 minus 4, and you can see you get -2, which is less than 1. This is still a true statement. No great revelations here at all. You've done all this before with equations. Now we're carrying it into inequalities. So let's take a look at this problem. It says solve x plus 3 is greater than 10. Check your solution and then graph the solution on the number line. Well, we're going to do this just like we would have done it if it was an equation, meaning there's an equal sign instead of a greater than sign. So diving into it, part A in solving the inequality, we're going to take and write the inequality first. Just like always, the first thing you need to do is write your problem. If you don't write your problems, I cannot give you credit for doing your homework because I can't check them. From there, we're going to use the subtraction property of an inequality, taking away x's friend. 3 is adding itself to x. The opposite of plus 3 is going to be minus 3. And when we subtract 3 on both sides, what are we left with? We're left with x on the left-hand side, and 10 minus 3, that equals 7 on the left-hand side. So now my new inequality says that x is going to be greater than 7. And yeah, for some reason we are going to put a 7 right here too, just to make everybody happy. Actually, they screwed up. That right there should be a 10. X plus 3 is greater than 10 is equal to x is going to be greater than 7 for your final answer. Now, checking the solution of an inequality is a little different than checking the solution of an equation. Here, they took and picked a number that says you can check that x is greater than 7 by substituting a number greater than x in the original inequality, because it says that our solution is greater than 7. So the number they picked that was greater than 7, that was 8. They stuck an 8 in for x. X plus 3 is equal to 11. Ask yourself, is 11 truly greater than 10? It is, so that means that your answer, well, not being guaranteed to be right, at least we know that we're on the right track here. The next thing we get to do is we get to graph this inequality. So in graphing it, First thing I need to ask myself is this going to be an open circle or a closed circle? Is it or equal to, or is it not or equal to? And this one is not an or equal to. There's no line under it. And since it's not an or equal to, it's going to be an open circle. Now, the way you remember that, go way back in the Wayback Machine when you were a little kid. And when you were a little kid and you first started plotting things on a number line, did you plot it with an open circle, or did you put a solid dot there? You put a solid dot there because that spot represented that number. Same thing, if it's an or equal to, if there is a solid yes, that spot represents that number, you have a closed circle. However, if it's not an or equal to, you're going to have the open circle. So we're going to choose an open circle and we're going to put it right there. Figure out how to get it to go there. And hold on. Well, it does not appear that this resource is working correctly, so let's talk about what we'd actually have here. You're going to put an open circle on the 7, because it's going to be greater than 7, and then the side that's greater than 7, that's going to be this side over here to the right, so we will start at 7, and we're going to draw an arrow going that direction, and you should have an arrow here on this end, not a circle. But you would start at 7, draw an arrow going all the way to the right, and that would end up being your final answer, which if we take and check it, I think it's going to check right. It doesn't check right, and I'm really not sure why, because x is greater than 7. So which of these solutions are not going to be valid solutions for x is greater than 7? Well, it's going to be this one right here for starters. That one's definitely not going to be it because it is not an or equal to. If it was an or equal to, then it would be a valid solution. How about this one here? Negative 7? Nope, that's going to be way down there to the left. That's not a good one. But these other two numbers, they're both totally valid solutions for x is greater than or equal to 7. Even though they're just a little bit greater than 7, they're still going to be greater than 7. And now it's going to be your turn. Isolate the variable, find the solution, and then check your answers. Now, just like any equation, the final goal of any inequality is to isolate the variable. For this inequality, my variable is going to be, let me get my cursor working here. Oh, hold on, I got an issue. Alright, I think we're good now. The variable is going to be w. W's friend is going to be 8. 8 is adding itself to w, so we're just going to subtract 8 from both sides, just like we would have done if it was an equation. 8 minus 8 is going to be 0, so we'll put a line through them because those are going to go away, and that's going to leave me with w is greater than or equal to 4 minus 8. Signs are different. Find the difference. Sign them from the larger number goes in front of your answer. And so that's going to be a negative 4, and that's going to be the solution to our system of to our inequality. Now, on the number line, as far as your homework goes, I'm not going to ask you to take and do this long number line with a million tick marks in it. This is what I'm looking for. I'm at negative 4. It is an or equal to, so I'm going to put a solid circle, and then the alligator is going to eat the w. The w is bigger than negative 4. Since the w is bigger than negative 4, we're going to draw an arrow to the side of the graph that's larger than negative 4. That's all I have to see for that. Jumping back over to our textbook page, first one we're going to say is that w is greater than or equal to a negative 4. We're going to check that. That part checks. And then let's see if this graph piece will actually work for us. So we're going to need a solid circle on negative 4. And it's going to be greater than negative 4, so it's going to go that direction. There, that time it actually worked correctly. We should be able to check the answer. The answer checked correctly. And that literally is all there is to doing these problems. Nothing to stress about at all. This is where we're going to end part 1 of this video. Come back and watch part 2, where we will continue our study of doing addition and subtraction inequalities.